Hello and welcome from the Journey Museum and Learning Center. My name is Christine and I'm the Education Coordinator here. Have you ever looked at all the rocks around you and wonder why there's such a big variety? Why do they look so different? We have different colors, textures, different sizes, and even shapes. Well, there are different types of rocks that are made through different processes. Today, we'll talk about that process, which is called the rock cycle. Now, one type of rock in the rock cycle is the igneous rock. Igneous comes from the word ignite, which means fire. Think of it when you ignite a candle. Well, underneath the Earth's crust, there is molten hot liquid rock. And one way that magma, this molten rock called magma, can enter the Earth's crust is through a volcano. And when it comes out, then we call it lava. And this is one way that rocks are formed. So look at all of this lava here and notice all of these bubbles. Well, what happens is that lava begins to cool off and harden and turn into rock. Well, along with that, actually, some of those air bubbles, because it cools so quickly, can remain in the rock, such as this rock right here. You can see the air bubbles all over here. Other rocks do cool even quicker than this rock. And that would be an example like obsidian. Obsidian can cool so quickly, there are no air bubbles that show up at all. So another type of rock in the rock cycle is sedimentary rock. It has the word sediment in it. Sediments are little broken pieces of rocks that come from another rock that already exists, such as the igneous rock we talked about. So the thing is, you could have, let's say, a mountain made up of igneous rock, and some erosion is going to come off of that mountain. So let's pretend this is our mountain right here. So what will happen is, let's say, rain comes or spring water or water from the spring, the runoff comes, and it breaks up the igneous rocks. And as it does, it breaks it up into little tiny pieces of sand. And watch what happens as I pour this clear water. It's all kind of yellowish down here because all those broken little pieces of the sediment have come here at the bottom. And look, it even has little broken pieces of the sediment here at the bottom. And what happens is when this water, where the rivers are, say, is you start to get these different layers of sediment. So right here I have a jar of different color sediments. Orange at the bottom, green, and then red. What happens is as the water leaves behind some of the sediments, more sediments go on top and leave behind more. So now I have even more sediments right here on top. And it starts to get this kind of layer of sediments, and pressure can occur as that sediment is on top of each other, and it starts to have so much pressure, it becomes hard and it becomes rock. Here is an example of a sedimentary rock. Notice the layers that you can see. Now, I'll tell you about the last type of rock in the rock cycle, the metamorphic rock. It metamorphosizes, morphs, it means to change. So in this example, I took the sedimentary rock that I already had. So a metamorphic rock takes a rock that's already in existence, and then there's heat or pressure that's applied to the rock, and it metamorphosizes, it changes it to another type of rock, a metamorphic rock. So I took that sedimentary rock, I added some heat, I added some pressure, And see how it just kind of partially melted here? That's a metamorphic rock. Now, metamorphic rocks can also form from igneous rock. So basically there are three ways to get that heat or that pressure. So one way is a sedimentary rock. As more sediments get on top, it gets lower and lower and lower, and eventually starts to go back into the Earth's crust near that magma, that molten lava, right underground, that magma, and it starts to heat that sedimentary rock and cause it to be metamorphic. Or you might have two plates that are rubbing together, and as they do, that pressure from the plate tectonics can also cause metamorphic rock. Or finally, you could have lava that would come in contact with the rock and make it metamorphic. So let's put it all together. Why are igneous, sedimentary, and metamorphic rocks considered part of a rock cycle? Well, I found these two pictures off the internet which can help you understand. On the left, we have the three different types of rocks, and it shows that any of them, through different processes, through the Earth's processes, can change from one type of rock to another. The image on the right shows a cross-section of Earth's crust and all the different ways that the different rocks can change from one type of rock to another. So the examples I talked about today would be an igneous rock mountain eroding, forming sediments, and forming into a sedimentary rock. Another example I talked about took the sedimentary rock, like those layers we saw, and we talked about how they could go further into the Earth's crust, and with heat and pressure can make a metamorphic rock. Well, if it goes far enough into the Earth's crust, it can actually join in with magma and then become magma, and it kind of resets it all together. So right here, I have that sedimentary rock from earlier that I then added some heat and pressure to change it into metamorphic. I added more heat, more pressure, and now it's formed with just one color and basically went back to magma. I let it cool, and since it cooled, it is now an igneous rock. There's the rock cycle. So thanks for joining today, and I hope that you learned something about the rock cycle, and now you can go find your own rocks and start to learn more about them.